So quick show of hands. How many people are here for the second year, second Elm Europe? All right. Wow. Okay, and how many people think this year is even better than last year? Yeah, all right, yeah. So please give it up for the organizers and the speakers. It is not easy to make something this awesome, and lightning striking twice is even better. Cool. So this is Make Data Structures. I'm Richard Feldman. So I want to start by doing a little bit of reflecting back on in particular, the way that I got into Elm, the first project that I ever did that was my sort of introduction to Elm. It's this, Dreamwriter. So this was an application that I built, and like many of the projects we've heard about so far, it was sort of something I wanted to do to scratch my own itch. I like writing fiction, back when I had a lot more free time, and I was kind of like unhappy with all the different fiction writing applications I'd tried, so I was like, hey, I'm a programmer. I'm going to scratch my own itch and build my own thing. So there were a couple of design goals I had. One was I wanted to focus on chapters. I had this idea of chapter centricity, like I wanted per chapter word counts. I wanted chapters automatically on the left. I wanted to be able to navigate between them, but I still wanted this sort of big view in the middle of like the whole document in the editor. I wanted everything to work offline, so I am on airplanes periodically, so I wanted everything to work even if I didn't have Wi-Fi. Now, Wi-Fi is more common on airplanes, but it's still quite often unavailable, so I wanted everything to work offline and to have it use IndexedDB to store things in the browser, so if I hit refresh, I didn't lose the entire 80,000 word novel I'd been working on. And finally, I wanted syncing, because as with any good writer, you don't want to have no backups and then suddenly discover that all 80,000 words were safe and sound on your hard drive, which then crashed. So these were sort of my big picture design goals. And the first version of this I built was in JS. And it got unmaintainable after a while because literally I felt afraid to make changes. Like when I would make changes, it would just break so many other things that it was just like, oh, okay, I'll just deal with the bugs that I've inflicted upon myself rather than trying to fix them, because fixing them creates worse bugs. And when I eventually in 2014 got into Elm and rewrote it, suddenly, hey, making changes was something that was actually quite easy. And this was sort of, to me, like the biggest deal about Elm was like, yeah, I can actually like make changes, and then once it compiles again, it just works again. It's like wow, maintaining things. And so I didn't really think until many years later that there was sort of like maybe stuff that I'd missed, like fundamental stuff that I'd missed in the way that I built that initially. Sort of a part of the trip down memory lane, I was for this talk, I was going back and looking at some of the early commits. This is a fun one. Migrate to Elm 0.14. That was back in 2014. So I remember there was some good stuff in that release. 19 is going to be even better. And this is the first commit. I like the commit message on this one. Add a giant mess of first attempts hackery and tomfoolery. October 11th, 2014. 990 additions and 0 deletions. And you know, as like amusing as this is to look back and be like, oh yeah, I was just like stabbing around in the dark, didn't really know what I was doing. I actually highly recommend this approach to learning something. Just kind of diving in and being unafraid to get dirty and just being like, yeah, you know, I don't actually know what I'm doing yet, but like, I'll learn what to do later. And just kind of embracing that and from the get-go being like, yeah, this is going to be a big mess, but I'm going to learn a lot. And then later on, I'll refine my technique. Fortunately, I actually have refined my technique now. It's been about 4 years, and I've learned a lot of stuff in those intervening years. And so I want to just kind of like go back and ask this question, like what advice would I give to my past self? If I could go back, like back when I really didn't know what I was doing, and say like, hey, here's something to focus on, which if you do it right, will actually lead to an even better experience than just the bar of you can make changes again, but actually like, oh yeah, you can make changes again and you can prevent these bugs, you can make things go better, you can have an overall better experience, get the project done, make more progress faster if you follow this guideline. So what advice would I give to my past self? Wow, so many things. I mean, it's just like a mountain of stuff. I just like look back, I was reading these commits and just like, I did what? Why would I do that? But I didn't know, right? And so I try not to be too hard on my past self. But I try to just boil it down and be like, okay, like what's the one big thing? Like there's lots of little things, but what's one big thing that I would do differently? And what I came up with, the #1 piece of advice that I would give to my past self to sort of set myself on the right path was, make data structures. Now, that's a phrase that's sort of succinct, but not extremely clear without context. So I want to spend the rest of the talk sort of giving context and explaining how to apply this idea of make data structures and using DreamWriter as a specific example and going back and saying, if I'd taken this advice, what would I have done differently? What would that have looked like? And how does it relate to applying this idea in practice? OK. So applying the advice to DreamWriter. So I'm going to start off by talking about like what I did and what problems I ran into, and then use those to contextualize what I would do today following this advice. OK, what I did. So I'm going to talk about 4 things here. First is the build order, like the order in which I built things. Second is JavaScript interop, which I did quite a bit of. The module structure that I came up with, and some of the data structures. Just reflect on each of these. Start with build order. So basically my priority when I was building this was I wanted visual feedback. This is something that a habit I'd gotten into from JavaScript. I was like, OK, I'm going to start by getting the layout done. I'm just going to get the basic skeleton of the page, got these 3 columns, editor in the middle, sidebars on the side, get that up on the screen. No content yet, but just kind of get it rendering. And then I'll build out the editor and just kind of like get that stuff working, make it so when you type, it updates the word count, things like that. And then I'll build out the sidebar and sort of build this like one block at a time and get visual feedback along the way. So building with blocks is sort of like how I've termed this approach, like saying like I'm going to build one block at a time, and then I'm just going to sort of glue them together later on. And this was very familiar to me from object-oriented programming, which kind of encourages these self-contained blocks objects and that have their own state and manage all that, and then you kind of glue them together, and that's sort of how you build things. Having recently come from React with its component model, which are objects, that's sort of the same idea. It's just like gluing these things together and then making something bigger out of the smaller pieces. OK. JavaScript interop. I was using a lot of obscure web platform APIs at DreamWriter. Full screen, file reader, exec command, blob, downloads, IndexedDB, and text selection. Wow, yeah. As you may have noticed, not all these have first-class support in Elm, which meant that I was doing a lot of, what's the word? I was doing a lot of harbors, no, ports, yes. Lots of stuff with ports. So I got very familiar with those very early on in my time with Elm, because I just needed to do all these things. Module structure. This was a fascinating one to reflect on. So I've sort of upgraded this to modern Elm syntax because the syntax was a little bit different back then. But effectively, I started with like module main exposing everything, import dreamwriter.doc exposing everything. Probably would not expose everything from that module these days. Import dreamwriter.model exposing everything. All right, definitely would not expose everything from that one as well. And then for some reason on this one, I decided to only expose view. I don't know what my methodology was there. But since then, I've kind of gotten a better appreciation for the role of modules in Elm, like what they're for. And now kind of understanding them better, I look at this and I'm like, why did I make these? Today I would actually not put the model into its own module or the view into its own module. I would say, no, those both go with main. That's kind of where they live. I would just do these as basically just headers, like little comments that's sort of used to divide up a file. That's kind of an old school way of doing it, but it's very effective, and it sort of keeps modules for their intended purpose. So if all I'm trying to do is organize the file, I can just say, yeah, like this section is for model, this section's for view, this section's for helpers. It's not just model, view, and update. These headers can be for anything. It's just like a markdown file, right? So you sometimes have headers to logically divide different sections of your content. So that's probably what I would do today instead of doing those things. There's a lot more on this topic. Evan talked about it last year. He gave a whole talk called The Life of a File. Highly recommend it. He talks about like the distinction between files and modules and like when to split things out. Awesome talk, which sort of influenced me to like understand these things a lot better. And finally, I want to talk about the data structures that I created. So this was one that I made. Module dreamwriter.doc exposing doc, chapter, new doc, and new chapter. So the way these interact is a doc is short for a document. So that would be the entire document that I'm editing, all 80,000, 100,000 words of this novel. Like I said, I have this idea of chapter centricity, so documents are broken up into chapters, and then the chapters themselves actually hold the content, like the text itself. I had a notion of new doc and new chapter, and that was important because due to various syncing things, I ended up concluding that the right design for this was to generate a SHA, like a hash for the idea of these things locally, randomly generate one, and then assign it to the document, assign it to the chapter, etc. So I was like, okay, I'm going to need all these. I made a type alias for my doc, so it's just a record. Had ID, which was an identifier. Get back to that in a second. Had a title for the document, and then a list of chapters for the chapters inside of it. Type alias chapter, I just had heading, string, and nothing else in there. I assume I was planning to get back to that and add more stuff because I made it a record, but that seems reasonable. I think likely that I would end up with more metadata inside chapter. So this ID identifier thing, this is in a different module called Dreamwriter. So I had Dreamwriter.identifier. I don't think this was a good idea in retrospect. And it also exposed this thing called new identifier, which was supposed to generate the identifier from like a SHA, like randomly generated SHA hash. So I had type alias identifier equals string. I was pretty hype about this. I was like, yeah, this is cool. I can like have it be a string, but I can make it more self-documenting by using a type alias. And then I had new identifier equals hard-coded string foo, and they said fix me should be SHA-1, but I didn't really know how to do that yet. So I was like, this will work out. But if you think about it, knowing what I know now, I look at this and I'm like, okay, first of all, this is a top level value, so I would definitely put a type annotation on it. The type annotation would say new identifier is a string. Now, if you're thinking what I'm thinking, you're thinking, oh really, that's going to be randomly generated and the type is string. This is going to work out. There are quite a few types you could use to randomly generate a new SHA identifier, but string is not one of them. So that, you know, is just par for the course when you're kind of like playing around in the mud, you don't really know what you're doing. But still, I highly recommend this method. Like I said, you know, make mistakes, it's part of the process. So then we had the new doc function, which takes the title, a list of chapters, and then gives you back a doc. So I had ID calling new identifier, by which I mean giving it the hard-coded string. Title equals title, chapter equals chapters. Yeah, so this is not going to work because since I'm trying to randomly generate this identifier, I actually have a sort of like propagated the problem now to new doc. So new doc says it returns a doc, but that's not going to work because it needs to generate this ID. So there's like a couple ways I could do this. One would be a command. That would work. I could say like new doc returns a command that's going to run random.generate. What I would like even better is something like either returning a tuple of random.seed in doc, or even better than that, returning like a random.generator of doc. Any one of these would work. What I did would not actually work. Fortunately, this is Elm, so I'll be able to fix it. You know, I had this sort of like confidence that I'll be able to refactor stuff later and go through and fix it, which sure enough I was able to do. Okay, now having said that, I should note that although I'm able to fix it, that doesn't mean this is the most efficient path. Like, it's definitely faster to do it right the first time and then not have to go back and fix it and fix all the implications of, you know, the things that I built on that. So this is what I ended up doing. Again, did not know what I was doing. I did in JavaScript. I was like, I don't know how to generate a random SHA, but I know how I did it before, so I'll just call that function, pass it in through a port. Port's all the things. Again, just can't stress that enough. Today, I would actually just use a package for that, and then just do it all right in Elm, and I wouldn't bother using commands. I would just do like a random generator and go from there. Okay, so that was what I did. Let's talk about the problems I hit along the way. Okay, first one, race conditions. Those are always fun. Text selection, that's always fun. A regrettable refactor, and word count. Okay, so race conditions. Right when the application starts up, the first thing that it does is it asks two different sources for the current document and then sort of reconciles them and then falls back on the default doc. So it asks the server, it says like, hey, you know, you've been syncing, maybe there's a new doc, like the current doc that I'm editing, that based on when I was logged in somewhere else, and you know, I need to get that updated one. Also, I'm going to ask IndexedDB for a doc because depending on the last modified timestamp, I may have been doing a bunch of editing while offline, and I may have been doing some other stuff somewhere else, and maybe I need to resolve those before actually showing something to the user. And finally, if I don't have either of those, that means I'm probably opening this for the first time, and I just should use the default doc. So this worked most of the time, but here's the thing. When you've got concurrent operations like these two right here, potentially you can have race conditions, which I did. And I know this because sometimes I would see the symptom of I would open the page and it would be like, correct, and then a second later it would like change. I'd be like, which one's correct? I don't know. And I'd get scared and I'd refresh the page and then it wouldn't reproduce and I'd be like, okay, whew, dodge that bullet. But I never actually figured out like which one was like winning the race or losing the race, or like how it was, like why it was doing that. So that was like one bug that I had. Text selection, so quick show of hands, how many folks have worked with the JS text selection API? Okay, so a very small number. Here is my review of the JS text selection API. Picture's worth 1,000 words. Not going to go into much more detail than that, but I think those of you who raised your hands can probably empathize with that. That was just a whole category of problems unto itself. So there was also a regrettable refactor, which I did and then subsequently wished I hadn't. You can probably tell from the PR, the name here, what I did. This is something I've subsequently talked to other people who have done it and who have also regretted it. So again, coming from an object-oriented React background, I was of the opinion that the correct way to organize front ends in general, regardless of what their architecture might be or their language or things like that, was to organize them into components that each hold their own state, and which I interpreted to mean they each have their own model, view, and update. So I refactored these things, like the editor got its own model, view, and update, and the sidebar did, and the other sidebar did. And I was like, yes, this is going to be much better. And then I actually went to try and do stuff with this, and I was like, what have I done? I suddenly hate this code, which used to be like the favorite, like why I got up in the morning was to work on this code base, and now I hate it. How did this happen? And at the time I was like, but that's the correct way to do it. So I don't know, I must have just like done it wrong, and I'm just gonna like move on to other projects, and I just like kind of walked away from it. I was just like, I don't know why I don't like this anymore, but like I'm sure that was a good refactor because that's like what you're supposed to do. So I don't know, something's wrong, but I don't know what, and I'll just like come back to it later. And I got plenty of other side projects to work on anyway. Which I super regret. Like that was just like a completely self-inflicted wound. I just didn't need to do that. It was much better before, and it was not until much later that I realized that, oh, actually you're not supposed to do that in Elm. That's a React thing. I gave my talk last year on sort of like what to do instead, based on having learned the hard way, sort of that hard lesson. And finally, I want to talk about word count, which was a problem that I ran into. Now, this sounds like a somewhat innocuous thing, right? I mean, word count, right? Like, it's like there's the words, and that's it. It's like 226 words saved. What's the problem? Well, there's a couple of problems. So one is I wanted it to update in real time, which like as you type, update the word count. That's a pretty reasonable thing, I think. But I also wanted to have an entire novel in here, which is like 100,000 words. And it turns out if you're going through the DOM and counting all the things in there, because like you kind of have to count DOM nodes, because what if you got like bold versus italics and underlined? You can't just like work on the raw text, or else I potentially get false positives. Then there were also sort of like these interactions that it had, because I also wanted to have this like chapter-centric notion of word counts, right? So like for each of these chapters, I could see the word counts for just that chapter. And like those, of course, had to, if you added all them up, it was very important that that added up to the number for the whole document. And if that wasn't true, that would be a big problem. And then I realized that I wanted to have it, when I hit open file, I wanted to be able to see all the documents. I also wanted to see their word counts right in there. So this actually needed to be persistent on disk, because certainly if I had like 100 documents in there, I wasn't going to open that up and then read all the files and then count all the words in all the files every single time just to display them in the open thing. So it's got a little bit more complicated, and I had several different pieces of the application that were like using the word counts in different ways and updating them in different ways, and they all needed to agree, but in practice, when I sort of optimized for 100,000 words and had this like multiple sources of truth thing going on, the end result was like unexpected interactions between them, which manifested in symptoms of word counts that did not agree. So I would look at my per chapter word counts and I'd be like, hang on a second, this says that, but if I add up all these, it's not the same. Uh-oh. So this is kind of a nasty bug to deal with, and unfortunately I couldn't fix it the easy way by just saying, well, hey, view is a pure function of model, so I'll just calculate them all on the fly, because it was too slow. And it was especially too slow if I was opening files. So I kind of needed this multiple sources of truth thing for performance reasons, but unfortunately that resulted in these bugs. Okay. So what I've learned since then is that actually these symptoms that I was seeing, with the word count example in particular, actually kind of like come with the territory of building with blocks. So the idea of like the building with blocks approach is like get one part of the UI working, so like get the skeleton working, get the main editor working, get the sidebar working, get one part working, get another part working, and then wire them together. The problem with that is that like when I'm prioritizing visual feedback like that, I'm sort of ignoring the wiring until the last possible minute. And by then, it might actually be quite difficult to get right. So I'd sort of like built in terms of isolation, like assuming that these things were isolated. Like I built one in isolation, I built another in isolation, I built another one in isolation, but they actually were not isolated. Like that was a fiction I had imposed in my brain. I was like, oh yeah, these are totally separate. It's going to be beautiful and elegant, until the real world kicked in and said, actually, these are coupled. It turns out they have interdependencies. They were not actually isolated, but I'd been sort of reflexively designing that way because that's like kind of what OO's thing is. It's like build isolated things and glue them together. And I've also seen this somewhere else. I talked about this last year. The Elm SPA example is one of the real-world example apps. And when I was playing around with some of the other ones, trying to understand how they worked, I encountered a bug with the React Redux one. So there was this thing called a global feed on this. It's like this Medium clone. You have like a feed of articles that comes out. And you're supposed to be able to click a tag thing and open up a new tab that has just that tag. So you could have global feed tab, or you could have like hashtag test, and it's going to show you all the articles with that hashtag. Now it's in a different tab, and you can switch back and forth between the two tabs, and that's fine. But certainly, you should never be able to get into a state where both tabs are selected at once. That doesn't make any sense. But sure enough, I did actually get in this state somehow by clicking around, and like so many of these bugs, it was hard to reproduce. But I did actually end up in that state. This is a good example of things that were built in isolation, but then when you put them together, turns out they don't quite fit. Turns out they actually had a dependency that was not originally captured when they were initially constructed separate from one another, as though they were isolated. And I found that this actually happens like more than I realized, because I'd just been taking it for granted that like this is just how software is built. Like all software has these problems, and like you can't get away from them. There's no solution. Just like you build in isolation, and like sometimes stuff doesn't work. And that sucks, but that's software. I didn't realize that like, oh, maybe you actually don't have to do that. Maybe that's just like one way of doing it, but maybe there's another way of doing it where you just actually don't have to have this problem, which is what we're building up to. So the idea is like, I want this to be impossible, right? This should be impossible. I want to make it impossible. So building with blocks does reveal isolated problems early, but unfortunately it reveals structural problems late. And this is especially problematic because structural problems are costly to fix after being built on. So if we're like back in the design phase and we're working on a building and we're like, oh, I see like after putting all these things together and seeing how everything fits together, I realize that there's going to be a problem where there's like too much weight on one side of the building. I'm going to correct that by altering my design and then saying I'm going to put some more weight on the other side of the building to balance it out. So that's one way of doing it. Or you could build all the pieces of the building and then put them together and then discover that now we have a big problem and it's going to be slightly more expensive to fix at this stage than it would have been at this stage. By the way, this picture is like incredible to me for several reasons. One of which is like there are stilts propping up the building, which I'm pretty sure I've done the programming equivalent of that in my life. And then there's like cars parked under it just bravely, like yeah, this is gonna be fine. It's nice and shady, right? I think that's the like SSH into prod, like sudo bash, yeah, here we go, right? So structural problems, yeah, like definitely I would rather catch them early than catch them after I built on that flawed structure and then I have to fix not only the flawed structure, but all the things that were built on top of it. So this is a good example of a structural problem, where the issue is not that each of these pieces in isolation is problematic. It's problematic when I introduce when I realize that they're actually interdependent, and I need to make sure that they stay in sync with one another. And changing model is a great example of making a structural change, and you can sort of see the expense of doing this. Like if you have a change to your model, what does that impact? That impacts view, update, init, subscription, I mean, everything, right? Everything ultimately depends on model, just about. So when you change model and you've already built all these things out, yeah, Elm does make it easy to go through and fix all those problems. It'll tell you like, oh, yeah, that's right, you need to make this change in view, you need to make this change in update, which is something I love about Elm. And that was one of my favorite things early on. I was like, oh, I can make these changes, and once it compiles, it just works. But the thing is, Elm might make it easy, but it doesn't make it free. I mean, you still have to actually go through and fix all those compiler errors. But there was no cost to doing this when these have not been built yet. If I'm changing my model before I've implemented view or update or init or subscriptions, it's no problem. All I have to do is make sure that the model is consistent with respect to itself, but the number of compiler errors I'm going to get and the number of things I'm going to have to go through and fix is much, much lower before I've implemented all these other things. Okay, so those are the problems that I ran into. And finally, let's get to the good stuff. Here's what I would do today instead. Let's see how it ends up impacting these problems that I ran into. Okay, so this is the advice. Make data structures. This is what I would go back and tell myself. Let's apply this. So here's how we're going to do it. First, we're going to design some data structures to capture the UI. So yeah, the model, but also other supporting data structures. So we saw like doc and chapter and things like that. Then I'm going to create interfaces to those, like put them in their own modules and actually think about what are the interfaces I should expose to one another? What are the guarantees that I want to create between these things? What are the impossible states that I actually want to make impossible? How can I do that at compile time? And finally, render them. Like once all of the wiring is done, once I've gotten it figured out how these things are going to interact with one another, then take that and start doing the stuff that I used to do at first and just say, okay, now I'm going to render this, add interactions, work on messages, stuff like that. Now I should note that there's the potential for over-engineering this in the same way that there's potential for over-engineering the blocks style. The danger here is to say, I'm going to design data structures not only to capture the UI that I'm planning on building for my MVP, but also for all possible future UIs that I might want to build. Just as much danger of doing that as there is with like over-engineering your layout and being like, well, it's going to be flexible in all these things, because what if I add a million things to all these different parts of the page? Right? Gotta watch out for over-engineering no matter which approach you're taking. But let's see how this approach works out in practice. Okay, again, here's Dreamwriter. We've got offline first, we've got chapter centricity, we've got these chapters on the left, we've got some buttons up here, which we'll get to a little bit later, and we've got word counts down here, which are affected by the things on the left and the things in the open menu. Okay, so first thing I like to do is start with a type, and I really mean the type keyword here, like a union type. So I'm just going to say type model, and then I'm going to represent the three different states that the model can be in, as far as I can see them. So right when I load the application, I know the first thing I'm going to do is I'm going to go to IndexedDB, I'm going to go to the server to try and sync, and I can essentially be in three different states. Either I am loading, in which case I haven't heard back from IndexedDB or from the server yet, because both of those are asynchronous, or I succeeded, in which case I'm good, I'm rendering all of this stuff, everything's great, or I hit some sort of failure case, like IndexedDB was empty or like corrupted or something, because the browser can evict stuff from IndexedDB. It's really fun. Don't read the docs on that. You'll have nightmares. Or maybe do, because I guess it's good to know these things. Or the server could be down, right? The server could give a malformed response. All sorts of bad things could happen. So I'm going to have some sort of problem type, which I'll make later. But certainly, if we're in the failure state, I want to capture that so I can show the user a message and say like, hey, something went wrong, sorry. Rather than just being like, hey, this doesn't look right. Why not? I don't have any feedback. But these are, of course, not, this is not complete. This is not enough to represent all of this stuff. This is just sort of like the basic like fundamentals here. Certainly in the success case, we're going to want a doc, right? I mean, we need a doc to render this whole page. That's sort of fundamentally the main thing that we're dealing with here. So if we're going to have a view function that's going to take this model and render this after loading has succeeded, we're going to need a doc for that. But then I start thinking about the implications of that. Like, I've got this union type. I've said fundamentally these are my three states, loading, success, and failure. But like, do I want the doc in any other cases? Well, I can't have the doc in the loading case because it's not loaded yet. That's the whole point. What about in the failure case? Well, if I don't have the doc in the failure case, all I've got is the problem, which means that's all I can render with. Which means if like the server's down, it's just going to have to have a message that says, I'm sorry, something went wrong. And then I'm like, okay, now what? Like, what? I mean, I want to write still. I'm sorry the server's down, but can you just like show me something so I can do stuff? So like thinking through this, I'm like, okay, yeah, actually I want a doc there too. Like in the success case and in the failure case, I still want a doc, but in the failure case, I additionally have the problem that I want to display to the user. And then I can transition between the two. Like I'll have like a little message, the user can close that, and then I can transition to the success case where it's not going to render the failure message anymore. Okay, and we can refine this later, but this is like the basic, fundamentally, here are the different states that should be possible. And as far as I can tell, so far, we're in good shape as far as like making impossible states impossible. There's nothing that here that is possible that I don't want to be possible. Cool. Okay. Last year I talked about this sort of cycle that I like to go through when I'm building Elm applications. There's like step 1, build, and then step 2, discover, where I like look at stuff, and then based on what I've just built, I sort of like realize things about it that I hadn't necessarily considered, sometimes with help from the compiler. And then based on that, I refactor. And then after I've refactored, I go back and build again. So we're going to apply the same process. It's just that what we're going to do today is focus on just doing that with data structures, not doing it with view and update and all the other stuff. We'll do that afterwards. Okay. So we've got our model, loading, success has a doc, failure has a problem and a doc. Now I'm thinking about, okay, so let's go back and look at this problem. And I sort of noticed something about this that came up earlier on, which is these are concurrent operations. Like I'm going and loading something from the server, I'm asking IndexedDB for a doc, and then eventually I will fall back on the default doc. But potentially those can come back in any order. I don't know whether the server is going to come back first or IndexedDB is going to come back first. But either way, I can't resolve both of them until I hear back from both of them. So at some point, I'm potentially going to be in the state where I've heard back from one, but not from the other. So I need to store that. I need to put like something like a maybe doc inside loading and say like, okay, maybe I've gotten a doc from the server, maybe I got one from IndexedDB, but I need to hold on to that so that when the other one does come back, I can resolve potential merge conflicts, whatever, and then decide on a doc, and then I can transition to the success case. Okay. But also another thing that could happen is a problem could happen. Like what if the server comes back and says, hey, server's down, sorry. I'm like, okay, but I'm still waiting for IndexedDB to come back. Okay, well in that case I also need to have like a maybe problem. So here I have like loading with maybe doc and maybe problem, and I learned this cool technique from Evan, which he apparently discovered when he was working with that person on typing of the dead, like he talked about in his keynote yesterday. And it's a pretty cool technique. And the idea is to expand out these states and confirm that all the combinations of these maybes that I put in here are actually states that I want to allow, and see if there's any, like, have I introduced any impossible states that should be impossible, and if so, what can I do about that? By the way, I have a whole talk about this if you're not familiar with the concept. I'm just kind of hand-waving away what that all means. So here's how I would expand out those states. So loading has two maybes. I could have a doc or a problem, neither or both. So having expanded this out, I can now look at this and say, okay, do these all look reasonable to me? Well, nothing means I haven't gotten back any docs from either the server or IndexedDB, and I haven't heard back about any problems. That's certainly valid. That's like what we start off with. So that one's good. What about the next one? So I've heard back about a document, but I don't have a problem. Yeah, that's also fine. That's totally reasonable. I heard back from the server, let's say, it had a document for me, but there was no problem. Next state would be I have no document, but I did hear back about a problem. Again, that makes total sense to me. I heard back from the server, but it said, hey, the server's down. That's the case where we added that maybe before. What about this last case? I have a document and I have a problem. Wait, how do I have both? I've heard back from one of them, and what that one said was, here's the document. Also, I couldn't have a document for you. There was a problem. That doesn't make any sense. I should never be able to reach this state. That state should be impossible. If we hear back about a problem and a document, we should have already transitioned to failure. Okay. Well, I don't have to represent this as two maybes. I can just make more union types, right? I can actually make this thing impossible. Here's how I can do that. I can change this to loading, which means I have neither of them. I can say I loaded one, in which case I heard back and I got a document. And I can say I'm still in the process of loading, but there was a problem. And I'm just recording that problem for later. So eventually, if I'm in this state, I'm definitely going to transition to the failure state. If I'm in the loaded one state, I'm definitely going to transition to either the success or the failure state, depending on whether the other one comes back with a problem. So now, I've accurately modeled all the different possible states that my app can go through on init. Okay, this is pretty cool, and it's sort of like why I like to start with a handcrafted type instead of like a prepackaged type. Like usually I wouldn't actually even start with a maybe like that, and that goes for maybe, result, remote data, etc. Like, I mean, sometimes I go through this exercise of like, okay, what are all my states, and just kind of think it through the implications, and maybe it ends up fitting one of these exactly. But quite often it doesn't. And like this is true of Dreamwriter. Like Dreamwriter has these particular states where it doesn't fit neatly into any of these categories. But that's because of Dreamwriter's particular business logic. If I had different logic for how I wanted to resolve these things, or maybe I had 3 sources instead of 2, there's lots of ways that I could end up modeling this differently. So I'd really encourage you to start with a handcrafted type and then work your way up towards something that works. And then if you see that it slots neatly into one of these, then maybe consider changing to it, or maybe even not. Okay, so we've now modeled all these states. Looking at this though, I'm like, okay, so what am I going to do in terms of rendering? I'm just like thinking ahead. I'm not actually writing my view, but I'm just thinking about it. All of these are just going to show a loading spinner. So that's pretty easy. Like if I'm in my view and I'm doing a case expression on this model, all of these are just going to show a loading spinner, and then both of these are going to show a normal page. Then I'm thinking, okay, well, this is actually going to be a little bit annoying because if I have this in a case expression, each of these are going to have to call out to 2 different view functions, one of which takes a problem and one of which doesn't. well, that's kind of annoying. Probably what I'll actually do is I'll have one view function that takes a maybe problem, and then it displays either displays or not the little message bar saying like, hey, there was a problem. So I think at this point, based on this, I'm going to go to the refactor cycle now that I've discovered this, and just refactor this, and I actually will use a maybe there. I'll say, so I've got my 3 different loading states, and then once I have loaded the doc, I maybe had a problem along the way, which I'll tell the user about. And then when the user dismisses it, I'll change the maybe to a nothing. OK, cool. So we've still got these concurrent operations that can fail, but do we have a race condition? Can we have a race condition? Like, how would I model a race condition using this? Like, how would I possibly get into a state where I'm going to be surprised about what gets loaded? It's actually a lot more difficult than it used to be. And now, by thinking through this and thinking like, OK, what are all the different states? How do I want to transition between them? What are the different scenarios that can happen? I've actually sort of like ruled that out. Maybe it's still possible if I sort of like went out of my way to induce one, but if I just write normal logic that populates this model, it's going to be fine. So like concurrent operations that can fail are just like a bug haven. They're notorious for having lots of bugs, race conditions, lots of problems. And all I did to prevent them in this case was literally I said, I'm going to start by making data structures. And I'm going to start with a union type. That's literally all I did. And now I've saved myself the pain and frustration of dealing with that race condition, which before was actually so painful and so frustrating that I just threw up my hands and said, I'm just going to live with it. Just by starting with data structures and thinking about the types and just thinking about the implications, I ended up solving that with one union type. Pretty sweet. OK, so let's continue with our like build, refactor, discover, or build, discover, refactor cycle. So here's our current model, and then I'm going to focus on this part of the UI next and make sure that we have enough stuff to model that. So there's 5 buttons up here. The first one is new document. I don't need anything new for that because that's just going to change the doc if we're in the loaded state. Second one is open document. That's a menu. It's going to have like some state for whether the menu is open or not, so we're going to have to introduce a little bit of state for that. So we'll add menu on here. Next one is download. Nothing needed there. It's just going to read the current document and then download it in the browser. Print, same deal, just going to read the current document. And then finally, we have settings. And we're going to want to put some state for settings in there, the different things the user can configure. OK, so this is totally fine, except for this is kind of awkward. This now has like quite a bit of state going on here. We got doc, maybe problem, menu, and settings. I would kind of rather have these have names than just be sort of like jammed together like that. So I'm going to put them into a record. That's easy enough. I can just put a record right there in the union type. But really, then thinking a little bit further down the line, probably what I'm going to want to do is I'm going to want to like pass that record to like something like view loaded and just render the page. That's going to be probably where the meat and potatoes of my view is living. So I'll just pull that onto a type alias called loaded model, which just has that record, and then the original model can reference that, and then I can write my view loaded function, which takes the loaded model and goes to HTML message. By the way, just for future reference, we're not actually going to go through and implement the view yet, but just to kind of talk through how that interaction works, because this is kind of a good general pattern in Elm. So view, of course, takes the model, like the top-level model, and returns HTML message. The way we can implement this is in terms of basically like delegating to a helper function. So we would do a case expression on model. If it's loaded, we're going to call view loaded model, and that's it. That's that whole branch of our view. We're done. If it's still in the loading, then we're going to render a loading spinner, and then the other cases are also going to do the same thing, viewing loading spinner. And that's it. So my top-level view can be really, really concise like this. It's just one case expression that's just going to dish out to these other helper functions. This is something I like to do all the time. Do it with view, do it with update, do it with anything that I can. It's just like start with some function that's got a bunch of different sort of like branches, different pathways that it can take, and just write top-level helper functions for each of them and just kind of dish out to them. So as it happens, in this version of things, I'm going to spend most of my time in here. I'm probably going to write view itself, like it's almost done. I just couldn't fit the rest of it on a slide. And then view loaded is going to be what all my commits are going to be touching from then on. Or helper functions that view loaded is calling. So basically, so far, building data structures has actually given me a better understanding of the app. Like just saying, like again, nothing else other than saying start with the data structures and like flesh them out and make impossible states impossible. Just thinking through all the implications of this and just asking basic questions like, can I get in this state? Should I be able to get in this state? Has given me a deeper understanding of the app. I'm understanding how things fit together better. I'm understanding the structure better. And what's cool is that I'm not doing actually like more work to do this. I'm building the same app. This is like work that theoretically I'd have to do even if I were building with blocks. I'm just doing it in a different order. I'm doing the wiring first and making sure I understand that really well before doing the view, rather than like jumping back and forth between them as I'm building. This is something, by the way, that I think is unique to Elm. I'm not aware of like any other, like unless you actually have the Elm architecture as like your only way of building things, I'm not really sure that like this necessarily works, and especially not if you don't have the compiler helping you out. Okay, once more through the build, discover, refactor cycle. So we've got our model. It's got loaded one, loading problem, and loaded with our loaded model, which is our type alias for that record. We built out the load model. Let's define problem real quick. That's just going to be a union type that's sort of like, either it's a server problem, in which case we have an HTTP error that we can use to render whatever happened to the user, or a database problem, which is a string. That's it. Nothing more needs to happen there. So let's move on to doc, which is going to be the, sort of the more interesting one. This is really the core data structure of our model, like the document itself. Module doc, exposing doc. First thing we need to figure out is like, what's the identifier going to be? So let's say we start off with an int, because I think I actually did start off with an int and then later changed it to a SHA, but for now let's just use an int. So say type alias doc ID equals int, so that we give it a little bit more of a nicer name. That was similar to the identifier trick that I did earlier, just make it a little bit more self-documenting. Or I could do type doc ID equals doc ID int. Quick show of hands, how many people have seen this technique? Okay, so that may have been everyone, almost everyone, very close. So this is basically making a union type with one constructor. And you might be wondering, if you didn't raise your hand, why would you do this? What would the benefits be? So let's say that I went with the type alias approach. And I wrote some function called getDoc, which takes a doc ID and then goes to the server and says, give me that doc. And then I also said, I defined a function called getRelated, which is like, give me an integer for like the number of related docs I want to get back, so I don't get like 1,000 of them if there are a bunch that are related. And then the particular doc ID, and that gives me back a request. Okay, so I could call doc, call getDoc passing doc.docID. That'll compile, give me back an HTTP request. I could also call getRelated passing doc.docID and then the results per page. That'll compile and that'll give me an HTTP request. Does anyone see the bug? Yeah, so it's easy to note because I'm talking about this topic, but in the real world, it's quite easy to do this and have it compile and then be very surprised at the results that you're getting. You call getRelated and it's like, I didn't find that document. You're like, what? It's right there. What's the problem? And the problem is that both of these are an int. So if I mix up the argument order like I did here, it's still going to compile. It's just not going to actually work. In contrast, if we do it this way, it will work because this is actually a distinct type from int. And if I pass the arguments in the wrong order, it won't compile because this union type is not equivalent to an int. Now, if I'm going to do this, I can't use like an int decoder anymore. I actually need to define a doc ID decoder, which is, I mean, it's a one-liner. It's just like decode.map, decode.int. Same thing with encoding, also a one-liner, but I do need to define those separately. So what I could do instead is I could move these into their own module. I could say module doc ID and expose doc ID, encode, and decoder. And these are just sort of like the decoder and encoder for this thing. And any other stuff that's related to doc ID can go in here. And another thing that I can do is I can choose not to expose the constructor. So previously I had exposing doc ID, parentheses dot dot, which is to say expose the doc ID as well as the constructor so you can pattern match on it. But what if I just don't do that? Now I've created an opaque type. Show of hands, who's heard that term? Cool. So opaque type is essentially just a type where you can't mess with it. You can't look inside of it. You can't pattern match on it to see what's going on in there. And you can't modify it. You can't take it and just say like, oh, I'm gonna again like pattern match to restructure it. All you can do is work with the functions that are exposed that exist in the world that work in terms of that type. So right here I've said, okay, there are two ways to work with doc ID. You can encode one. Given a doc ID, you can turn it into a JSON value, or you can decode one from JSON. That's it. You can't make one by hand. That's like a design decision I've made, and it's something that I'm able to make because I've made this type opaque. Okay. To sum up, this tells me if I mistakenly use an int instead because it's a union type, I can also change the internals without breaking other code. So it's an int right now, but if I end up changing it to a string, which in fact I did end up doing because I wanted to make it a SHA, I can just do that and be completely certain that no other code is depending on that and potentially breaking. Also, I just get this nice code organization, docid.decoder. That's like a very neat way to reference that. Using like qualified module names is a really common pattern in Elm. Okay. In contrast, with problem, I actually would choose to expose the constructors. And the reason for this is that problem is basically an enumeration. I'm just saying, like, here are the different values, and I actually want people to pattern match on this thing. That's a choice that I want to make. In particular, I want anyone who's using this type to pattern match on it, and ideally not use the empty pattern match, because if I introduce new potential problems, I want that code to break. I want it to no longer compile so that at all the different call sites that we're relying on this, I know, oh, okay, I need to change it there, I need to change it there, I need to handle this there, etc. In contrast, I actually don't want that if I'm working with this ID. I want to be able to hide the internals of that. We'll see how that can be a little bit more valuable momentarily. Once more through the cycle. So we've got doc ID exposing encode and decoder, but we actually can't use these primitives that we've exposed to handle the new doc case. Like, what happens when I make a new doc and I need to generate a new SHA from scratch? So we've changed it from doc ID int to doc ID string. Cool. That's a good start, but now I need to do the thing that I didn't know how to do back in the day, which is to generate it. Fortunately, I do know how to do that now. And so what I can do is I can expose a generator and say generator, and it's just going to be a random.generator doc ID. That's it. That's the way you can get one of these. And I'll expose that too. And what's cool about this is that I've made it very clear how this API works. Again, you can decode one of these from JSON, or you can randomly generate a new one. You cannot give me a string and make one. I just do not permit that in my API, because that's not how it's supposed to work. I've encoded that right here in this module. I've said this is how you get new ones. You can generate a new one at random, or you can get one from the server. That's it. So the entire interface for this type is in one module with an obvious name. It's just doc ID. So I see doc ID.decoder, doc ID.generator. It's pretty cool. OK. And finally, we get to the doc module itself. So doc is going to have also an encoder or decoder. It's going to also have a generator for generating new docs, which is going to delegate out to the doc ID generator. And again, that problem that I had earlier was like, oh, I actually have this function that claims it's going to return a doc, but that's not actually going to work. I've now made it very clear in the type, yeah, if you're going to make a new doc, this is how you do it with one of these generators. It's going to generate the random SHA. There's no other way to do it. So if I want to really have that guarantee, that means I'm also going to need to make doc an opaque type. So I'll have it be single constructor. I'll have a record of the different things going on here. Doc ID, title, chapters, same kind of stuff that I had before. Now, if I've got that and I've got my generator, there's a little bit of a trouble here that I didn't have with doc ID, which is I actually do want to be able to change some of these things. I don't want to let users change the doc ID really, but I do want to let them change the title. Like, they can type in and change the title. I also certainly want to let them edit the chapters. That's like mainly what they're going to be doing. But I also need to be able to read these out directly. Like, doc ID needs to be able to be read, but it's an opaque type. They can't access this record. So how do I expose the ability to do those things? Well, I can just write a function. I can say, here's a function called doc.docID. Takes the doc, returns the doc ID. That's basically a similar number of characters to just saying, like, I have this record and saying .docID. It's just, instead I'm calling a function. Same thing with title, same thing with chapters. So exposing those three functions makes it so that now these are sort of like read-only, but I still haven't let users modify them. They still can't peer into this opaque type. So if I want to let them modify it, what I have to do is expose something like map doc ID, which takes a doc ID change in a doc and then returns a new doc with that changed. And same thing with map title and map chapters. OK, now if I'm doing all this, I might say, well, yeah, but I actually don't want to let people modify the doc ID. So I'm actually just like not going to do that one. I'm going to expose map title and map chapters, but not doc ID. So I can maintain the guarantee that still the only way to have a doc ID is to generate it or to read it from JSON. OK. Now, if you're like me, you might be thinking of this and being like, I don't want to do all that. That's a lot of functions. That's like 5 functions. Yes, they're all one-liners, but 5 times 1 is 5, which really adds up fast. So, you know, rather than doing that, this one-time cost, and then like having these guarantees, what if I just sacrifice the guarantee? It's like, it's just the doc ID. It's fine. But OK, just for the sake of argument, let's say that we didn't do that, and let's just see where that takes us. Let's say we actually did write the 5 one-liners and maintain that guarantee. What might happen as a result of that? So this would be our API. We're saying we've got exposing doc, encode, decode, and generator. Doc ID, title, and chapters are readable, but only title and chapters are writable. Doc ID is not. OK, there's one more that we need, which is words. Remember that whole word count ginormous bug that we had? Yeah, that's got to be exposed too. Note, by the way, that just by exposing this function, words, which is going to take a doc ID and return an int, I haven't actually said how it's implemented internally. Like, maybe it's calculating it every time. Maybe it's caching it. Don't know. Don't need to know. Can't know. Anybody who's using this API doesn't know about that and can't really rely on that as an implementation detail. So let's say we expose this function. Okay, word count strikes again. So just to recap, the problem that we had was we have total word count down there, but that actually interacts with all these other things on the side, and even with the open menu. So when I had 100K words, performance problems, I needed to start caching this stuff. Okay, caching. How can we cache this? Well, we've got these things. Doc ID is read-only, title is read-write, chapters is read-write. Now I'm going to add words and make that another one of the read-only ones. So as it happens, I'm storing it internally, but again, nobody outside the module can write to this thing. Only I, as the author of this module, can write to it. Which means that cache invalidation, which by default is a very, very scary thing, has suddenly become not scary. Check it out. Where are all the possible things in the entire universe that could change that? They're all in this module. How do I change them? Well, if I need to set the cached value, I'll make sure the decoder does it. Like when I'm decoding the word count, if I don't get it from the server, I'll calculate it and cache it. The generator itself, when I generate a new one, I'll set the word count to 0. And then map chapters might need to recalculate it. Done. That is 100% of the ways in the entire universe that this cache will be invalidated. And the entire universe of like possible ways that it could get invalidated is all in that module. I don't have to look at any other code or worry about that. Again, remember, this was like the buggiest part of my code base, and now I've made it trivial to maintain. These things are never going to get out of sync. It's so easy. And in fact, I could just introduce a cache later, right? Initially, we didn't have this words part of our API. Look how few lines of code it took and like how little effort it took to add that. No problem. So yeah, this does require a little bit more effort up front. I get it, and I felt that before. But I really regret like looking back the amount of times that I said, yeah, but like 5 lines of code, and I missed out on stuff like this. And then I ended up with these nasty bugs, and I was like, this was not avoidable. There was no way I could have possibly avoided this. But actually, it turns out there was. It was in many cases because I was like, oh, but the boilerplate, you know, and like rather than doing something that I knew would get me a few extra guarantees, I was just like, but like 5 lines, come on. So to sort of like sum up the trade-offs here, and like this is how I conceptualize it. Say like writing accessors and mappers is what we do for opaque types. If we're actually exposing the internals, then you know, fixing race conditions and fixing caching bugs become a lot harder. Like this stuff is quick and easy, no matter what. It's like very easy to write these functions. They're one-liners. Exposing them takes no effort. But these things are actually very slow and difficult, and this is like a really concrete downside of exposing your internals. Like fixing really hard problems becomes significantly harder, and then like doing easy stuff is still really easy. So now when I'm making this mental trade-off, I'm like, yep, I'm just gonna write those, that's gonna be fine. Okay, so to summarize all the things we talked about. So first I was like building with blocks, right? Get one of the part of the UI working, get another part of the UI working, and then wire them together. As a result, I ended up with bugs of this nature, where things should have been impossible, but I built them in isolation, then when I glued them together, they didn't quite work as intended. So I asked this question, like, what advice would I give my past self? And fundamentally, it's this. Make data structures. Like, focus on that first. Like, start by thinking about what data structures am I going to use to represent my application. So design data structures to capture the UI, create interfaces to them. Notice that as I was going through this, I spent a lot of time thinking about what my modules were exposing. Like, what union type values should they have? What should be internal? What should be external? And then finally, rendering them. And we didn't even get to that part because once you've got your model nailed down like this, rendering becomes much, much easier. You don't have to think about this stuff on the fly. You've already thought about the sort of the design of the system as a whole. And finally, you know, implementation-wise, start with a type, go opaque by default, and yeah, maybe you'll end up deciding that you do actually want to expose everything, or maybe you have an enumeration and you want to expose everything. But if you're not sure, default to opaque. And finally, do the build, discover, refactor loop. Some of the talks that I referenced earlier, highly recommend checking them out if you haven't seen them. Life of a file, scaling LMAPs, making impossible states impossible. Also, shameless plug, as Guillaume mentioned earlier, I'm teaching an Intro to Elm course, which is probably not useful to any of you, but starting in August, there's going to be an advanced Elm course as well, which may be interesting to more of you. And I'm also writing Elm in Action, and that's available for MEEP. So thanks very much.